So now let's look at parametric equations. So remember, parametric equations are just these. You know, we have x is a function of t and y is a function of t. And there are a bunch of different questions you can ask about these. But here's a pretty common one, which is to find the equation of the tangent line at some t. So let's go ahead and work through that. And just to remind you, point-slope form, y minus y naught is equal to m, which is the slope, times x minus x naught. And, you know, these problems are pretty self-explanatory. The only sort of issue that we kind of need to go over is this m, which is the slope. So m is going to be dy dx. But we have x's and t's and y's and t. So we want to find dy dx using x of t and y of t. And to do that, we're going to use the fact that dy dx is equal to dy dt over dx dt. And if you see what happens, these dt's cancel out, and we're left with this dy dx. So to find the slope of the tangent line, the derivative, we're going to take the derivative of y of t with respect to t and divide that by the derivative of x of t with respect to t, and that'll give us the derivative of y with respect to x. So let's just work through this problem. These really aren't that difficult. It's a lot of plugging in. So let's first of all solve for x naught and y naught. X naught is going to be equal to x4, because t is equal to 4, which is equal to 3 times, I'm just plugging in 4 into x of t, 3 times 4 squared minus 4, and that's going to equal 3 times 12 minus 4, 44, and y naught is equal to y of 4, so I just plug it into y of t, and that's just going to give me square root of 4, which is equal to 2. So now let's go ahead and rewrite this equation with what we have so far. We have y minus 2 is equal to m times x minus 44. And now we get to this part where we need to solve for m. So remember that m is equal to dy dt over dx dt. So dy dx is equal to dy dt over dx dt. And I'm just going to go ahead and do that. The derivative of y with respect to t, I'm just going to rewrite this as t to the 1/2. So the derivative of that is going to be 1/2 t to the negative 1/2. And I'm just going to write that as 1/2. And instead of t to the negative 1/2, I'm going to put root t on the bottom because those are equal. Divide that by the derivative of x with respect to t. X is over here, so the derivative of that is going to be 16 minus 1. And we're going to be evaluating that at t equals 4, because that's our point of interest. So that's going to equal to 1/2 times the square root of 4 over 6 times 4 minus 1. That's equal to, square root of 4 is 2. 2 times 2 is 1/4 over 24 minus 1 is 23. And that's equal to 1 over 92. So that's going to be our m. So we're going to plug that back in here and just rewrite the equation of our final line. Y minus 2 is equal to m, which is 1 over 92, times x minus 44. So once again, parametrics, not too difficult. just remember that dy dx is equal to the derivative of y with respect to t over the derivative of x with respect to t.